Okay, in this video, we're going to start learning some new trigonometry tools in order to solve triangles that aren't right triangles. So, for example, if we look at triangle A, B, and C, I want to solve x. The first thing we notice is it's not a right triangle. I've got no right angle, either A, B, or C. So that means I can't use just SOHCAHTOA, just those primary trig ratios that we've learned previously. I can't even label the sides opposite, adjacent, and hypotenuse because there's no right angle. So which side is the hypotenuse? We couldn't even start. So instead, we're still going to label the triangle. And as we've discussed before, we're always going to have the lowercase letters represent sides. And each side length should be opposite the corresponding capital letter angle. So across from angle A is side little a. Across from angle capital B is side little b, and across from angle capital C is side little c. So we're still labeling the triangles. We're just not using O, A, and H because, again, it's not a right triangle. What we're going to use instead to solve these problems is something known as the sine law. I've got two versions of the sine law up here. They're really the same thing. All the sine law is saying that if I take any side length and divide it by the sine of the angle across from it, that proportion or that ratio is going to be the same for each side angle pair in the triangle. So A divided by sine A is always going to be the same as B divided by sine B, which is the same as C divided by sine C. And it doesn't matter if I put the side lengths on top, or here I put the sines of the angles on top. They're still going to be equal to each other, right? Just the same way, like we know that 1/2 is equal to 2/4. And if I flip both of those fractions, well, 2 over 1, which is 2, is the same as 4 over 2, which is also 2. So flipping the fractions isn't going to change this relationship. I'm going to use this version of the sine law today when I'm trying to find a side length. And I'll use this second version when we're trying to find an angle. So again, trigonometry can help us find missing sides and also missing angles. So all we need to do is set up the ratios. So I'm looking here. What I want to find, I'm going to put in the top left in the numerator. So I'm going to have side B. That's what I want to find. And then its corresponding angle, I'll take the sine of. So I'm going to have B over sine B. And on my right side of my ratio, I always need a complete pair. So to use the sine law, we can only use the sine law if I have the complete pair of a side and the angle across from it. So you notice here, I don't know side A and angle A, but I do have a complete pair of side C and angle C. So on my right side, I'm going to put C over sine C. So this right side always has to be what I call a complete pair, a small letter and a capital letter. And then up in this top left corner, that's where we're going to put what we want to find. And now, again, I'm going to start with this target. It's not related to this particular triangle. And then I'm going to start plugging in the information that we know. Well, I don't know B, that's x. That's what I want to find out. But I do know angle B, so I have sine 70. And then I've got 8 over sine 35. So again, anytime I'm putting an angle into a formula, it's going to be preceded by a trig ratio. The side lengths just go in directly. And then again, well, what is B? Well, B is x. That's what we're trying to find out. And again, we can solve by cross multiplying. So I'm going to find the diagonal that doesn't include the variable, and I'm going to multiply those together. So I've got 8 multiplied by sine 70. And then I'm going to divide by whatever number is left over. Sine 35 is just a number stored in our calculator. So that's going to be my solution to x. So I'll have 8 sine 70. Whoops, 8. Let me get away from the glare here. 8 sine 70 divided by sine of 35. And so x will be 13.1, and our units are centimeters. So we're always going to round side lengths to the nearest tenth to 1 decimal place. It can be a little bit difficult to check answers in trigonometry. We're really relying on our calculator. One thing we do know is that the largest side is across from the largest angle, and the smallest angle is across from the smallest side. So they have to correspond, right? Because 70 is a bigger opening than 35. So the side across from it is going to be longer or wider than the side across from the smaller angle. So yes, 13 is bigger. 13 corresponds with 70 because 70 is bigger than 35 and 13 is bigger than 8. So that's one way we can sort of check our answers. in any type of trigonometry problem. Okay, this time we're going to solve the triangle, which means I want to find all three sides and all three angles. Again, we don't know that this is a right triangle. It doesn't look like one, so I can't use SOHCAHTOA. I can't label the sides O, A, and H. Instead, I'm going to label the three sides with the lowercase letters opposite from the corresponding capital letter angle. So I've got sides lowercase p, r, and q. So I've got to find three missing pieces of information, angles P and Q and side P. Let's start by finding angle Q. So I'm going to use the version of the sine law that has the angle in the top left. What corresponds with sine Q? Well, it's going to be side Q. Then again, on the right side, I need a complete pair. I don't know angle P and side P, but I do know angle R and side R. I'm going to use this version of the sine law. Notice the actual letters don't matter. So in your note, I think you have A, B, and C. The letters, the names of the angles and sides are arbitrary. What matters is the relationship. So I should always have angle and side across, angle and side across. Again, what I'm looking for is in the top left, and then a complete pair of data is going to be in the top right. So let's start plugging in what we know. I don't know Q, that's what I want to find. I do know side Q is 19 meters. And I'm going to have sine of 66 divided by 25. So again, anytime we're putting an angle into a formula, into an equation, it's going to be preceded by the trig ratio. Side lengths always go in directly. Again, I can isolate in one step by cross multiplying. I find the diagonal that doesn't include the variable, so it doesn't include Q, so that's 19 multiplied by sine of 66. I multiply those together, and then I divide by the number left over. In this case is 25. So sine Q is equal to this ratio, but I want to know angle Q. How do I move the signs to their side? Well, we always do the opposite to move something across an equal sign. The opposite of the sine function is inverse sine. Sine minus 1 on your calculator. So I'm going to take inverse sine to look up this ratio and to find angle Q. Again, if you have a scientific calculator similar to mine, you can just punch this in directly. I'm going to do 19 multiplied by sine of 66, close my bracket, divide by 25, close my big bracket. And so angle Q must be 44 degrees. We're always going to round angles just to the nearest whole degree, so no decimal places for angles. So now I know Q is 44 degrees. So we can also use this sine law to solve for angles. Again, anytime we're solving for an angle, we'll be using our inverse trig function. So I found angle Q. Now, I could also find angle P. I could use trigonometry. It's always easier, much more efficient if I'm trying to find the third angle in a triangle. Well, I know they all sum to 180. So the measure of angle P would just be 180 degrees, subtracting the other two that we already know, subtracting R and Q. So by far, the quickest way to find the third angle in any triangle is just to subtract from 180. So P is going to be 70 degrees. Okay. Now all I need is side P. And again, I could just use the sine law again. I can't use SOHCAHTOA, it's not a right triangle. And again, I can't use Pythagoras because the Pythagorean theorem is only working for the right triangle. So instead, I'm going to solve for little p. Again, what I want is going to be in the top left, so I'm going to have p over sine p. And then I've got two complete pairs. So I could pick. I could either do q over sine q, or I could do r over sine r. They'll both work because I have both complete pairs at this point in the problem. Why don't we do r over sine r? And again, I should, when I set up my ratios, I'm always going to have one thing that I'm looking for, and I should know the other three. So I always have that complete pair on the right side, and then I can solve by cross multiplying. So I've got to multiply the diagonal that doesn't have the variable, so 25 times sine 70, divided by what's left over, so divided by sine 66. And again, I can put it in my calculator in one step. We only want to be using the calculator once per question, so I don't need to round in an intermediate step. So I want to type that all into my calculator. And so again, I found that P is 25.7, and I think our units are meters in this question. So I could add that to my triangle. I find sometimes it helps when I'm solving triangles to just be very clear about what I've found. So this triangle had 3 angles, P, Q, and R, and I now know each of them. So P was 70 degrees, Q was 44 degrees, and R was 66 degrees. And there are also 3 corresponding sides. So P was 25.7 meters, Q was 19 meters, and R was 25 meters. Sometimes I like collecting my data in that sort of therefore statement. It's going to reassure you that you have found everything. Also do a quick check. Sure enough, the biggest angle is across from the largest side. The smallest angle is across from the smallest side. And the middle angle, the Goldilocks, is across from that middle side. Okay, so that's how we can use the sine law to solve triangles. It works only when I have a complete pair of an angle and the side across to put on the right side of my ratio. We can use it to find angles and to find sides. And we use it when I do not have a right angle triangle, when I cannot use SOHCAHTOA. Okay, thanks for watching.